Density is the mass per unit volume of a substance. If I want to calculate density, I will simply divide the mass by the volume to get the unit of density. If the mass is measured in kilograms and the volume is measured in cubic meters, the unit of density would be kilogram per cubic meter. An alternative is to measure the mass in grams, to measure volume in cubic centimeters, so the unit would be gram per cubic centimeter, and this is the one that is commonly used. From the formula, we can calculate the mass by multiplying density times volume, or if I want to calculate the volume, I will divide the mass by the density. Density is a physical property of matter. Each material has its own density. For example, here density of water is 1 gram per cubic centimeter. Ice is 0.92 gram per cubic centimeter. This is why ice floats in water. Density of gold is 19.3 gram per cubic centimeter, which means if you need to check if your ring or a crown is made of pure gold or not, simply check its density. Density of copper is 8.9 gram per cubic centimeter. How to compare different materials that they have the same mass? According to the formula, density equal mass divided by volume. So if we have the same mass, this means the density will be inversely proportional to the volume. So if we have 4 liquids here with the same mass, but they have different volumes, as we can see here. The first one has a volume of 8 cubic centimeter, the second one has a volume of 4 cubic centimeter, 5 cubic centimeter, 10 cubic centimeter. So according to the equation, the one with the least volume will have the greatest density, and this makes B is the one with the greatest density. On the other hand, the one with the greatest volume, which is D, will have the least density. What about if we have different materials with the same volume? Here we have 2 cubes of equal dimensions, but one of them has a mass 5 kg and the other one has a mass 15 kg. Again, according to the equation, density equal mass divided by volume. So for the same volume, the density is directly proportional to the mass. But again, I am confirming this is for different materials. So according to this equation, the one that has the least mass will have the least density. The one with the greatest mass will have the greatest density. To measure density, we need to measure both mass and volume. To measure the mass, we may use the 2-pan balance, the top-pan balance, or the Newton meter. In the 2-pan balance, we place the known mass on one side and the unknown on the other side. In some cases, we may not be able to find the suitable mass. For example, here if this one is 100 gram and this piece of rock here is more than 100 gram, then you added another mass which say 5 gram, but this one became more. This means that the mass of the rock lies between 100 and 105. In this case, we can take the average 102.5. The top-pan balance would give us a reading that is accurate up to 1/100th of a gram, but still we cannot use it on a different planet. We can't use it on the moon. If I need to record the reading using the Newton meter, I have to calculate the mass by simply dividing the reading in newtons by 10, which is the free fall acceleration. Another way to find the mass is by comparing a known mass like 100 gram to the unknown mass that we need to calculate by using a ruler and a pivot, which is placed at the 50 centimeter mark, or maybe at a different point, but it must be level at the beginning of the experiment. So if we assume that it balances at 50 centimeter mark, all what we need now is to distance D1 between M1 and the pivot, and the distance D2 between 100 gram and the pivot. gram. Then we apply the formula M1 D1 equals M2 D2. In some cases, the object that we have is in a form of a cylinder, so it would be more accurate to measure the distance from the center of the object. So if we record the reading at the edges of the object, for example, here the reading on this side is 78.6, on the other side is 81. So the center here will be at 81 plus 78.6 divided by 2. So the center of this object is at 79.8. So in this case, if I want to calculate D2, 79.8 minus 50 equals 29.8 centimeter. Another way which would give more accurate result is to hang the known mass and the rock or the unknown mass that we need to calculate on the sides of a ruler that is pivoted at its center through a hole passing through its center. So in this case, we can directly measure the distance, since in this case the position of the string would give a more accurate reading on the scale of the ruler. In this example, the mass of a full bottle of cooking oil is 1.3 kg. When exactly half of the oil has been used, so this is half the mass of the oil is used, the remaining oil is 0.9, which means that the mass changed from 1.3 to 0.9, which means that there is a change in the mass 0.4 kg. This would give half the mass of the oil. So the overall mass of the oil is 0.8 kg. What is the mass of the empty bottle? So the mass of the empty bottle equals the total mass, which is 1.3, minus the mass of the oil, which is 0.8. This means that the mass of the empty bottle is 0.5 kg. To measure volume, we need to learn how to measure the volume of a solid object and a liquid. Solid objects can be either regular solids or irregular solids. Irregular solids can be either sinking or floating. A regular solid can be directly calculated by measuring its dimension. For example, if I have a cube, the volume of a cube is equal to the side length to the power of 3. For a liquid, we will use a measuring cylinder. For the irregular object, we will use the displacement technique, as we will see. Now, when we use a measuring cylinder, first we need to make sure that it's placed on a level. Then we need to pay attention to the water meniscus inside the measuring cylinder. And of course, when we record the reading, the line of sight must be to the lowest point of the water meniscus. And line of sight must be also normal to the scale of the measuring cylinder. Here we have 3 samples of readings on a measuring cylinders. Here the reading is 6, here is 7, so the difference is 1, and we have 10 divisions. This means that each division is 0.1. So the reading here is 6, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So the reading is 6.6 cubic centimeters. By the same way here, the reading is 40 minus 30 is 10, and we have only 5 divisions, so each division is 2. So if this is 40 minus 2, so the reading is 38 cubic centimeters. On the last one here, 20, 30, 10 divisions, so each one is 1, so it's 21, 22, 23, 24. The displacement technique. First, we need to add some water. Actually, some of the students normally say fill the measuring cylinder with water. If the measuring cylinder is full, you can't add any more objects to it. So we add some water to a measuring cylinder and we record the volume V1. Then gently we need to immerse the object that we need to measure. Here, if we have a piece of rock which is a sinking object, as we see here, the volume will change to V2. So in this case, the volume of the object is equal to V2 minus V1, where V1 is the volume of water only, and V2 is water and object. What if we have a floating object? In this case, we will use a cotton string and a sinker. The sinker here is a piece of metal that we will use to force the floating object to be immersed in water. So when we record the reading here, V1 represents the volume of water plus the volume of the sinker. When we pull it and tie it around the floating object, say this is the one, a piece of cork for example, and this is the sinker right here, the volume is changed now to V2. So V2 now is the volume of the water plus the sinker plus the floating object. So if I need the volume of the floating object, it will be equal to V2 minus V1. What if the object doesn't fit into the measuring cylinder? In this case, we use displacement can or displacement container. We fill the displacement container till the outlet like this. Then we gently again immerse the floating object. Say we have a statue like this one, which doesn't fit into the measuring cylinder. As you see here, the water will be displaced out into the measuring cylinder, where we can record the reading directly. 10 identical steel balls, each of mass 27 grams, are immersed in a measuring cylinder containing 20 cubic centimeter of water. This is V1. The reading of the water level rises to 50 cubic centimeter. This is V2 now. So now the volume of the steel balls is equal to V2 minus V1 equals 50 minus 20 equals 30 cubic centimeter. Now, if I want to calculate the density equal mass divided by volume. Now the mass. Here we are given the mass of a single steel ball. Each is 27 grams, but we have 10 of them. This means that the total mass is 10 times 27 divided by the volume, which is 30. So the density of the steel balls is 9 grams per cubic centimeter. A student used a suitable measuring cylinder and a spring balance to find the density of a sample of the stone. Describe how the measuring cylinder is used and state the readings that are taken. So first we need to add some water and record reading. Gently immerse the stone and record the reading. V2 So the volume equals V2 minus V1. Describe how the spring balance is used and state the reading that is taken. Hang the stone to the spring. In this case, the mass equals reading in newtons divided by 10. Write down an equation from which density can be calculated. Density equal mass divided by volume. The student then wishes to find the density of cork. Suggest how the apparatus and the method would need to be changed. Actually, in this case, no change. It's still the same displacement technique, only a sinker will be used.